Hey everyone, welcome back for another deep dive.
Always a pleasure.
So this time we're diving into something of a mystery.
Oh,
We're looking at cocktail party chemistry, specifically episode 121,
okay.
which is titled Chemical Vapor Depositions, Thin Films That Transform.
Sounds interesting.
Yeah, the catch is that we don't actually have episode 121. It seems to have vanished.
Oh, no.
But we're not going to let that stop us, right? We
Right.
have a whole bunch of other cocktail party chemistry episodes.
Yeah.
And we have factoids, so we're going to use those to try and understand
Okay.
what's so special about this mysterious CVD.
I love it. A challenge.
Exactly. It's like a little scientific puzzle. We have the pieces. Can we put it together?
Let's give it a try.
All right, so let's start with the basics. What exactly are thin films?
Right.
Why do they keep popping up all over cocktail party chemistry?
Yeah, that's a great question.
It's like they're everywhere.
Well, they kind of are. I mean,
Okay.
think about it. They're in so many different areas of research.
Yep.
For example, in episode 2, remember Therapeutic Treasures from Nature?
Mm-hmm.
That episode talked about lovastatin and how it's produced using thin films.
Right, to increase the efficiency of drug production.
Exactly. And then there's episode 17, Advanced Corrosion Protection and Environmental Solutions.
Yeah, they talked about biomimetic mineral coatings, which are also thin films.
Right, and those coatings are preventing corrosion, which is a huge problem.
And then we have episode 121 itself, which mentions CVD creating these thin films that transform.
Right.
So just from these examples alone, we can see that thin films are involved in a wide range of applications,
Absolutely.
from medicine to manufacturing to environmental solutions.
It makes you wonder what they all have in common.
Yeah, what makes them so useful across so many fields?
So basically, thin films are super thin layers that we deposit on surfaces.
Right, and these layers can be made of all sorts of different materials.
Exactly.
And depending on what material you use, you can give the surface all sorts of different properties.
Like making it more resistant to corrosion or wear and tear.
Or improving its electrical conductivity or its optical properties.
The possibilities are really quite vast.
So now the question is, how does CVD fit into all of this?
Right.
Well, the title of episode 121 gives us a clue: chemical vapor deposition.
Okay.
It explicitly links CVD to these thin films.
So CVD is a way of creating thin films.
Exactly. And the episode description tells us a little bit more.
Oh.
It says that CVD involves using vapors to deposit a thin coating onto a surface.
Interesting.
So instead of using like liquids or solids, we're using gases.
So how does that work?
Well, imagine you're baking a cake.
Okay.
You have your cake pan, your ingredients, and the heat of the oven to transform everything into a delicious treat.
I like where this is going.
So let's break it down in terms of CVD.
All right.
First, we have the substrate, which is the surface that we're going to coat.
Okay.
Think of that as our cake pan. It provides the foundation and the shape for our thin film.
Makes sense.
Then we have our vapor phase precursors.
What are those?
These are the gases or chemicals that we're going to use to create the thin film.
Okay, so they're like the ingredients in our cake.
Exactly. They're the things that determine the properties of the final coating.
So different precursors lead to different thin film properties.
Precisely. Just like changing up the ingredients changes the flavor and texture of your cake.
I'm getting hungry just thinking about it.
Me too. So then we have the heat of the oven in CVD. This is the energy needed for the process.
Okay, so we need to heat up those vapors.
Exactly. Under controlled temperature and pressure, those precursor vapors react, and they deposit onto the substrate, forming that thin film layer.
Wow.
And just like with baking a cake, we want that coating to be uniform and free of any defects or impurities.
So we're aiming for a smooth, consistent, high-purity coating.
That's right, just like a perfectly baked cake.
I can get behind that analogy.
So now we're starting to get a picture of how CVD works.
Right, but how does it actually transform things?
That's where the real mystery lies, and that's what we're going to explore next time on the deep dive.
Can't wait.
Yeah, stay tuned.
I'm hooked. Okay, so we've got this cake analogy going, but where does the transform part come in?
Right, that's the key question.
How does CVD actually transform things?
Well, one of the key aspects of CVD is the incredible level of control that it gives you.
Control?
Yeah, you can really fine-tune the properties of the thin film.
Okay.
For example, you can adjust the thickness of the film with amazing precision.
Oh, wow.
You can control its composition. You can even create very specific structures at the nanoscale.
Nanoscale, so we're talking really tiny.
Exactly, and this level of control is what allows CVD to transform materials and enable all sorts of cool applications.
Like what?
Well, think about electronics.
Okay.
Microchips and semiconductors, they rely on incredibly thin layers of materials with very specific electrical properties.
Right.
CVD is used to create those layers.
Wow, so CVD is essential for our modern electronics.
Pretty much. And it's not just electronics. CVD is used in a wide range of industries.
Like what else?
Well, how about solar cells? CVD can be used to create the thin film coatings that help solar cells absorb sunlight more efficiently.
So it's making solar energy more viable.
Exactly. And then there's medicine.
Oh, interesting.
CVD is used to create coatings for medical implants, things like artificial hips and knees.
Oh, right.
Those coatings need to be biocompatible so they don't cause any adverse reactions in the body.
Yeah, of course.
And CVD can create those coatings with incredible precision, ensuring that they're safe and effective.
It's amazing how versatile CVD is.
It really is. And that versatility stems from the level of control that it provides.
Makes sense.
It's like having a molecular toolkit. You can choose the right tools, the right materials, and the right conditions.
To create the perfect thin film for the job.
Exactly. And when you have that level of control, you can start to do some really incredible things.
Like what?
Well, remember how episode 121 mentioned the synthesis of novel nanostructured materials?
Yes.
That's where things get really exciting.
Nanostructured materials, what are those?
These are materials that are engineered at the nanoscale, meaning that they have unique properties
Okay.
that you wouldn't see in the same materials at a larger scale.
So like tiny particles or super thin wires.
Exactly. And these nanostructured materials have all sorts of amazing applications.
Like,
They can be used to create more efficient catalysts.
oh, right. I remember episode 3 talk about catalyst recycling.
Exactly. And CVD can be used to create those catalysts with incredibly high surface areas.
Which makes them more effective.
Exactly. And then there are things like carbon nanotubes.
Carbon nanotubes.
These are essentially rolled up sheets of graphene.
Graphene, that's that super strong material.
Right. It's one atom thick and incredibly strong.
Wow.
And carbon nanotubes can be used to create incredibly lightweight and strong materials.
So they could be used in like airplanes or spaceships.
Exactly. They have all sorts of potential applications in aerospace engineering and other fields.
This is mind-blowing.
It's like we're entering a whole new era of materials science thanks to nanotechnology and CVD.
So CVD is not just about creating thin films.
Right?
It's about creating entirely new materials with unique properties.
Exactly. And these materials have the potential to revolutionize countless industries.
Wow.
So CVD is not just a coating technique, it's a gateway to a world of possibilities.
I'm starting to see why episode 121 was titled Chemical Vapor Deposition, Thin Films That Transform.
It's all starting to come together, but there's still so much more to explore.
Okay.
And we're going to dive even deeper next time on the deep dive.
I can't wait. It's incredible how much we've learned about CVD.
I know, right?
Even without actually having episode 121.
It really is amazing what we can piece together just from other episodes and factoids.
Like we've been on a scientific scavenger hunt.
Yeah, and we found some real treasures along the way.
I mean, think about it. We started with this simple phrase, thin films that transform. And now we've uncovered this whole world of applications.
I know, it's mind-blowing.
From electronics to medicine to energy.
And it all comes down to this one technique, chemical vapor deposition.
Yeah, it's all about precision and control.
Being able to manipulate matter at the atomic level.
It's like we're playing with molecular building blocks.
And creating materials with properties that we never even dreamed of before.
It's pretty exciting.
It really is. So what do you think, dear listener? What's been the most surprising thing you've learned about CVD so far?
For me, it's the sheer versatility of this technique.
Yeah, I agree. It's incredible how many different fields it touches.
It's almost like a universal tool for material science.
And it's not just about creating new materials.
Right.
It's about improving existing materials, making them more efficient, more durable, more sustainable.
CVD is really helping to shape the future of our world.
It's amazing to think that something as seemingly simple as depositing thin films can have such a profound impact.
It's a testament to the power of chemistry and the creativity of scientists and engineers.
So as we wrap up our deep dive into chemical vapor deposition,
Uh-huh.
we hope you've gained a newfound appreciation for this incredible technology.
And maybe even a little inspiration to explore it further.
CVD is more than just a coating technique.
It's a gateway to innovation, a tool that's shaping the future.
So keep exploring, keep asking questions, and who knows, maybe you'll be the one to discover the next groundbreaking application of thin films that transform.
That's a great thought.
Thanks for joining us on the deep dive.
It's been a pleasure.